Hey everyone, Rob here. Welcome to module number 6, understanding the electrolysis of water. Okay, this is very important to know because this is the technology behind Kangen water, and people are going to ask you, okay, why is this different? What's so significant and what differentiates the technology? Okay, and this is what really, this technology is what Kangen water is produced from, and no other water that people are going to be able to go and buy or have access to is going to be anything similar to this. Okay, it's very different, and you want to be able to answer people's questions on why it's so different and how is it made, how is this water being produced. Okay, you don't got to be an electrochemist, but you want to have a basic understanding. That way, people can get the correct information from you. Okay, so let's do a little bit of history on electrolysis of water. Okay, so water electrolysis was invented in the late 19th century by a man named Michael Faraday. Okay, Michael Faraday invented many other devices, electrical devices, in the late 1800s. One of them being the capacitor. So some of you may already know what that is. It's in almost literally in every piece of electronic equipment you've ever used, and this man also invented and was the first one to discover or invent this technology. Okay, and the late 19th centuries, late 1800s. It's a very long time. Okay, that this has been in existence. Okay, so water electrolysis was used in the early 20th century. Okay, by the British Navy. They would use the salt water from the sea and produce electrolyzed oxidizing water for disinfecting and cleaning the ships. Okay, pretty neat. Military is always using technologies ahead of their time. So, you got all the salt water in the world on the ocean, and now you got electrolysis technology. Boom, now you have hypochlorous acid at your leisure, and you can disinfect. You got wound care. Okay, you got an antiseptic. You got a sterilant. Perfect. Pretty interesting. Okay, Russia and Japanese governments first analyzed the so-called healing waters coming from places like Northern Germany. They found that these waters that were naturally occurring had a higher pH and had molecular hydrogen dissolved in the water. Okay, so Northern Germany has a natural spring there that is one of these known healing waters or natural miracle water locations around the world. Other examples are Locote, Mexico. I'm not sure if I'm saying that correctly. And Lourdes, France would be another example. Okay, and in the Russian and Japanese governments are the first to really go and analyze samples of these different so-called healing water locations that people are lining up to by the thousands and still do today. So they can analyze and see the properties, and they did find that there was consistencies with these locations with all of these locations, and that were higher pH, the negative redox, and the molecular hydrogen gas. Okay, that was in the water. There was H2 in the water. Okay, so almost like a naturally occurring electrolysis process was happening in the Earth. Okay, the Earth is an electrical. The Earth is purely electrical. That's the best way to put it. Okay, there's electromagnetic fields. Okay, there's rocks that have different charges. Okay, there's electron transfers happening. So it is rare, but this is these properties were consistent with all these different healing water locations. Okay, so water electrolysis technology is used to simulate the same properties as these natural water sources. Okay, So by using electrolysis of water, they were able to simulate these properties, okay, by making a reduced water. And in my opinion, now they're doing this in a controlled environment where they're able to really hone in on specifics, okay, specific amount of current, okay, surface area of plates, really, and by doing this, they're able to maybe even enhance some of these properties. Okay, other examples where water can be ionized is when lightning hits a lake or a lightning storm on the ocean. Okay, that is going to create some temporary dissociation of water. It's going to create some electrolysis in the water. Okay, and release electrons into the water. Okay, getting those negative ions. Okay, the process of electrolysis only works when water has electrolytes dissolved in it. Electrolytes is a term that simply means a substance that can conduct electricity dissolved in water. Okay, we need electrolytes, but electrolytes is a fancy term that's thrown around really, and really all it really means is a substance, okay, a mineral, an ion that is dissolved in water that improves the conductivity of the water. Okay, so salt. You put salt in water, it dissolves in the water. Now, because the salt is conductive, okay, you've added electrolytes. That would be considered an electrolyte. Another type of electrolyte would be copper, okay, magnesium, calcium. Okay, sugar is not an electrolyte. So when you dissolve sugar in water, it does not improve the conductivity of water. Okay, so just by looking at the health risks associated with sugar from an electrical perspective, for me, that was a red flag. Sugar is not an electrolyte. We need electrolytes in our body so that the water is conductive. Okay, and water is not, or sugar is not an electrolyte, it's the opposite. Okay, so that was kind of an interesting fact that really, gave me that electrical perspective on why sugar is not healthy. Okay, distilled water or water that has a very low amount of dissolved minerals cannot undergo electrolysis because water is actually not a conductor of electricity. It is an insulator. If the water will not conduct electricity, there will not be a complete path or closed circuit for the electrons to move through. The more conductive the water, harder the water, the better the electrolysis process works. Okay, so water with a low ppm, okay, parts per million of dissolved minerals, or distilled water, RO, reverse osmosis water, they cannot undergo this process because pure water, pure H2O, I think we discussed this in a previous module, pure H2O is an insulator, not a conductor, okay? Which means it's no better, if you had pure water, it's no better at conducting electricity than wood, plastic, or rubber, okay? So you need to have the electrolytes, which is a fancy way to say I need some minerals in the water to make the water conductive. Now that I have a mineral water, okay, which a lot of our source tap waters and well waters around the world, the majority of them, they're going to have a sufficient amount of minerals. This process can take place in the device. So the harder the water, which means the more minerals, the better this process actually works because the water is more conductive. So you have a higher conductivity of water, the process can work more effectively. The issue is the harder the water, the more minerals, the more scaling is going to happen to the machine, so to the device. So if someone's living on a well, or they live in a city where there's the water's harder, they'd have to make sure that they're doing their e-cleans more frequently to make sure that they're descaling the machine, okay? But harder the water really means you're gonna get better electrolysis effects. So in my opinion, I'd rather have a harder water and have to do more cleaning than have a softer water, because I'm gonna have the electrolysis process is going to work more effective on that harder water. Okay, water electrolysis simply uses electrodes connected to a DC power supply. There are electrodes connected to the positive post of the power supply, and we call these the anode. Okay, so positive terminal of the battery or power supply is called the anode. And there are electrodes connected to the negative side, and we call these the cathode. So negative side of the battery or power supply is called the cathode. These electrodes in the enagic devices are constructed of 99.99% pure solid titanium that is durable and can withstand the heat generated by the electrical current. It's very important. This is one of the best. The plates of an ionizer is the engine. It's everything. It's the engine of this device. Okay, and when electricity is flowing through a wire or through a circuit, in this case, the wire would be the water, okay, or the load would be the water. It generates heat. Okay, that's just a byproduct. There's an electromagnetic field that's created, and there's always, for the most part, heat is generated. Okay, and power is lost through heat. So, if you don't have a solid, durable, quality metal, okay, that can withstand heat, you're going to end up damaging, degrading, and scorching these plates, and then this could actually become a health issue. Okay, so that's why a lot of these competition models that have a lower quality build of plate, their machines don't put out a lot of current. Okay, it's because if you tried to put 2.5 amps of current, like a K8 or ST501, through some of these other plates that are manufactured out there, they would melt them. They would burn them right up. Okay, so Enagic's plates are durable and they can withstand the heat and withstand the amount of current that Enagic's ST501 and K8 are putting out, that 2.5 amps, because it really comes down to the amount of current. The more current you can put through the water, the better the electrolysis process is going to be. You're going to be producing more H2. Okay, so they are double dipped in a medical grade platinum. The platinum is a highly conductive precious metal that is responsible for the almost instant occurring electrolysis process on the flowing water. Prior to the engineering of the continuous water ionizer technology, this electrolysis process took a lot longer. Okay, so that's the purpose of the platinum. The platinum is a precious metal. It's highly conductive, and the purpose of it is being so conductive that it allows the electrolysis process to happen quicker. Okay, almost instantly. So now instead of having the technology where they basically used to have two tanks of water, okay, with a semi-permeable membrane in between, so that way the minerals in the water could pass through the tanks, and they would have two electrodes, positive and negative, and then they would basically turn the power on and start to cook the water, and then the water over time, about 15-20 minutes, the minerals would migrate across the semi-permeable membrane, okay, and then you would produce O2, oxygen gas, on the positive, and H2 on the negative side. Okay, so that's how this used to be done many decades ago. Because of the platinum and the high conductivity of this metal, they're able to build these electrolysis chambers now and flow the water through over these plates, and because of the platinum, you're getting that instantaneous split in the water. Okay, so that's the purpose of the platinum. So the better metals, the quality of the metals and the construction of the plates and the quality of the platinum is very crucial to these products. And it's hard to get this information across to some people when they become their own online ionizer researcher. But if you can get this information across to individuals and they can really see that the enagic plates are untouchable on the planet. They're the best. Okay, so and that is the whole key to the ionization process. Okay, a simple way to explain water electrolysis is that we are decomposing water into oxygen gas and hydrogen gas using an electrical current. Okay, so that's a very simple way to explain it. Someone asks you, well, what is water electrolysis? Well, we're actually decomposing, we're breaking down or decomposing water into its original elements. So using electricity, okay, using a direct current, we're able to produce oxygen gas and hydrogen gas. The hydrogen gas is very therapeutic. There's always twice as much hydrogen gas produced than oxygen gas. It's a 2-to-1 ratio, okay? And that just makes sense. You know, you got 2 hydrogen atoms for every 1 oxygen atom in a water molecule. So when you disassociate water, okay, you're going to be producing 2 times more hydrogen than oxygen. When the electrolysis process is occurring, the different types of dissolved minerals or ions in the water will migrate to either the positive or negative plates, depending on their charge. Okay, so acidic minerals have a negative charge and migrate to the anode, okay, the positive plates, and the alkaline minerals that are positively charged migrate to the cathode, okay, to the negative plates. This is what is causing the plates to produce scaling. So the longer you run the product, the more of these minerals that are already found in your tap water or well water, okay, they're going to migrate and they're going to stick to the plates. And that's what's producing the scaling. So the water is alkaline because of that increase in hydroxide, but because of we're concentrating a lot of those already present alkaline minerals from our water and eliminating a lot of the acid ones. Okay, some water molecules will disassociate. This means that a hydrogen atom will be pulled away from a water molecule to receive an electron. Okay, this creates active hydrogen. This active hydrogen will merge with another active hydrogen atom and produce H2. This occurs at the cathode. At the anode, water molecules lose 2 electrons, producing oxygen gas and releasing 2 hydrogen and protons that will become hydronium. Remember, hydrogen protons never float around as little, they never stay in a liquid or substance by themselves. They will always go and attach themselves to water and become hydronium, or H3O. The amount of mineral separation and the amount of water being disassociated is controlled by the amount of electrical current used, okay? So if you want more water molecules being disassociated, okay, and if you want more the water to be alkaline, more alkaline, because the pH of the water is a byproduct, okay? So the more you crank up the electricity, the more you crank out the amps, okay, the more you increase the output of electrical current, okay, you're gonna be putting more electrons in the water, okay? Because you're putting more electrons in the water, you're going to be disassociating more water molecules, okay? You're going to be attracting even more of those alkaline minerals because you're creating a larger magnetic field, and you're going to be producing more hydrogen gas. That's why the water becomes more alkaline, okay? So you're really, when you're picking 8, okay, 8.5, 9, and 9.5 or 11.5, you're actually just cranking up the electrical current as you increase the pH, okay? So that's really what, having it set as a pH is an easy, more user-friendly method of doing it, but really, in order to achieve those higher pHs, you got to put more current through the machine. Okay, so as an example, if I'm making pH of 9 water, okay, there's a certain amount of current going through coming out of the plates, coming out of the negative plate, or there's a certain specific amount of current coming out of the power supply. When I go to 9.5, I'm going to be putting a little bit more current. Okay, there's going to be a little bit more current coming out of the power supply. Okay, and then to make 11.5, I've got to have a little bit more current coming out of the power supply. Okay, and in that process, I'm going to be creating bigger separations. So 9.5, 4.5, 11.5, 2.5. Okay, and I'm going to be producing more H2, more O2 on the positive side, and I'm going to be migrating more of those minerals. Okay. So electrical current is key to getting effective electrolysis effects on the water. Okay, now the electrical current is the key here. Okay, and that's why the construction of the plates have to be built the way Enagic builds them, so that they can handle higher amounts of current. Because at the end of the day, we want water. We're promoting a product that can deliver therapeutic benefits. Okay. Water electrolysis is not a filter system, and pre-filtration should be considered. It may vary depending on the geographical location of the source water. Okay, so I'm fortunate to live in a city where we don't fluoridate our water. Okay, so a lot of people live in cities that do not have that benefit. A lot of cities do fluoridate their water. Okay, the majority of cities in North America fluoridate their water. So a lot of people don't think it's a big deal. Some people do. So if someone asks you, do the Enagic machines filter out fluoride? No, they don't. Some will still be consumed because fluoride is an acidic mineral. So when you hit 9.5, a lot of the fluoride will go out the acid hose, but there's still going to be, some left in the 9.5. So you're not getting rid of the fluoride. So a recommendation for somebody who really wants to get that fluoride eliminated is to get a fluoride pre-filter, okay, with their Conga device. Okay, so pre-filtration is there. It's on the Enagic website, and it's going to change depending on people's needs or what's in their water supplies. Okay, so those are discussions you're going to have with your clients. Another thing, people on wells. Some people that there's different types of well waters out there. So some people's waters are harder than others or softer than others. So you really want to let them know, okay, how is your water hard? If the water is hard, you want to let them know that yes, the machine's going to work really well, but you're going to have to do your cleaning more often because you're going to be scaling those plates more frequently. Okay, so here's a great schematic that I use. This is all over the internet. And I use it I have it in a binder that I give to my clients when they're at my demos, or if I'm sending them up with water, I'll let them borrow a binder. And it's a great visualization that I can sit down and go through the stages of the water from the tap to the hose. Okay, it's very simplistic, and you can explain it. A lot of people learn through seeing, through visuals. Okay, so I really like this picture. It really gets the point across. It just shows the filter, the option of the electrolysis enhancer, and then it shows the water being split depending on the polarity, and then the two hoses, and very simple, and it really gets the point across. Okay, and this is another drawing that I like to use in my demos, and it really does get the point across too in regards to the electrolysis process. So like we discussed, the electrolysis process is decomposing water or breaking water down, okay, into oxygen gas on the positive and hydrogen gas on the negative. So this is a depiction of that. Here's that diaphragm, semi-permeable membrane, okay? And we have our two electrodes. So we turn on the power, So what a lot of people don't know is electricity doesn't flow from positive to negative, it flows from negative to positive. Okay, so electrons, if you see here, we'll analyze this schematic a little bit. You see the little arrows? So this electrode, the cathode, is giving off, okay, electrons. So think of it like a lightning strike hitting a lake. The lightning is just a bunch of electrons, okay, and it's giving off electrons. Where are the electrons coming from? They're coming from the power supply in the machine, okay, and it's using the water as a path to complete its circuit, okay. So on the negative side, electrons are given off. Okay, so this is important. This is why it's good to have a device that has a high current output, because the more current the machine can put out safely, the more of these electrons you're going to be putting into the water. Okay. Yeah, so electrons are coming off the cathode. Okay, so here, this is an example of a redox reaction. Okay, where the electrode, the cathode, is losing electrons, so it's being oxidized, and the water is being reduced. Okay, so we're creating a reduction here. There's a reduction here. We're gaining electrons in the water. The water is being reduced here, and because of this, free electrons that are being dumped in the water, a hydrogen proton will break away from a water molecule and attach to one of these electrons, okay? And then we get active hydrogen right here, this guy right here. That active hydrogen will come in contact with another active hydrogen, and then we get, boom, H2. That H2 is what you see bubbling out of the water, okay? And it's literally like it's boiling. It's like a form of boiling the water. You're bubbling H2. And the bubbles that you're actually seeing come out of the water, those are actually the ones escaping. There's such a higher concentration dissolved in the water that you can't even see with the naked eye. Okay? And that's really what the goal is to have that higher concentration that you can't see. Okay? So we're producing hydroxide and H2. Okay? And we got our alkaline minerals that are being attracted to the negative plate because of the opposite charges. So here's an example. We've got iron, sodium, calcium, magnesium, and potassium. So these are examples of minerals that could be found in your tap water already. Okay, and then let's look at the reaction here. Okay, so this little equation just explains what's happening. So for every 4 H2O molecules, okay, for every 4 electrons that are given off, we create 2 of these H2 molecules plus 4 of these hydroxides. Okay. Okay. So on the positive side, we have the opposite reaction occurring. Okay. We have electrons being given off. We have electrons being stolen from the water. Okay, so 2 electrons will be taken from the water molecule here. Okay, so electrons are being given to the anode. Okay, so the cathode gives electrons, the anode takes electrons. So give a reduction. This is oxidation. Reduction, oxidation. Okay. So electrons are being given to the anode, and if you look, we are completing that circuit, okay? Electrons are given off, and they're returned to the anode, and reduction, oxidation, and we have a closed loop. Okay, and that's creating that complete circuit, that path. But in this process, okay, the water is being oxidized. So when the water molecule is being oxidized, electrons are being taken from the water molecule. Okay, Oxygen has an oxidation number of 2, so 2 electrons are taken from the water molecule, okay, from the oxygen atom, and in that, what happens from that is we produce an oxygen atom and 2 H plus protons, okay? Those 2 H plus protons, like I've said in previous modules, H plus doesn't float around in a glass of a substance independently like that. It will always attach to another water molecule and create H3O hydronium, okay? So for every 2 water molecules that are being oxidized, okay, so let's look at the anode reaction. For every 2 water molecules that are being oxidized, we produce O2, okay? So O2 gas, which is oxygen gas, which is being released from the water, and 4 H pluses, or we can say 4 hydroniums are produced, and there's 4 electrons that are being removed from the water in this case, okay? Can't have a negative sign in a chemistry equation, so it would normally be 2H2O minus 4 electrons, but we can't have a negative sign in a chemistry equation, so we've got to bring the 4E over and I'll make it positive, so it's balanced. Okay, that's why if that's confusing, we're not adding any electrons, we're actually removing them. So 2 H2O molecules, okay, 4 electrons being removed, and you end up with oxygen gas, O2 gas molecule, and 4 hydroniums. Okay, and that production of hydronium, okay, is what's making the water acidic. Remember, you increase H plus or hydronium, the pH goes down. Okay, so you got a high concentration of H plus, a low concentration of hydroxide, and you have O2 gas bubbling out of the water. Okay, so with the escape of the O2 gas, this acid water has a very low dissolved oxygen concentration, which is why it's beneficial for watering, especially cut flowers or cut plants that you're keeping in a vase in the house. Okay, because flowers or plants breathe in carbon dioxide and breathe out oxygen. It's the opposite of humans. Okay, so that's why this the beauty water, or I'll even use the 4.5 for some plants to keep them around longer. It's really beneficial for plants, okay, for flowers. So yeah, it's and also here we have some negative. We got some negative minerals here. Those are acidic minerals: chlorides, sulfites, nitrates, okay, carbonates. They are attracted to their opposite charge, and that's another reason why the water is acidic. Okay, and the more electrons you can pump into the water, the more concentrated this process will take place. So for example, if you have a machine that puts out 1 amp, okay, versus a machine that puts out 2.5 amps, you're going to be putting a lot more of these electrons in the water, and you're going to be producing a lot more of this guy right here, okay, H2. So that's beneficial. So if you ever have anybody that's you're doing a water trial for, and then you warn them about what they're going to find online, so be very careful. I always tell people, let me provide you with information first. If someone does say to you, you know what, I think I'm going to buy one of these less expensive models that I found online, tell them, phone the manufacturer, or well, they're not even a manufacturer, phone the company and ask them how many amps, because a lot of them won't even promote it, how many amps the machine puts out when producing 9.5. Okay, and a lot of these ones that they're comparing to the ST501 or the K8, they're not even remotely close to being comparable. Okay, this is the magic. Okay, and in order to put a lot of these electrons in the water, you got to have plates that can handle okay, the amps. So the more current, the more dissociation of water, the more H2 production, the more therapeutic the water, okay? So that's about it for electrolysis. So we went through the history, just to show you how far back this actually goes. We went through, what inspired the technology, which is those healing waters, okay? And this is basically taking those properties and enhancing them. The purpose of the platinum, why it's important to have well-built plates, okay? How important the current is, and disassociation of water. And I really like these equations. They really break it down and show the oxidation and the reduction process, okay? And yeah, that's the simplest way I can put it. I hope that really helped make things more clear for you. And now when people ask you some questions about explaining the difference in the technology between why is Kangen water different? Okay, why is it better than that spring water? Why is it better than that, than just filtering my tap water? Okay, what's this electrolysis process all about? Okay, you'll be able to use these simplified, basic truths, okay, to be able to give that information to a client or your downline, and deliver that information to them. Okay, so that's it for module 6. I'll see you guys on the next module. Thanks.